Well, yesterday I was filming this engine running, and at the end of the day, the motor didn't behave right, and I was afraid there's something wrong, and I think it's in the armature. I noticed the armature had some cupping, which is usually a case of the brushes just sitting on the armature arcing, and I've polished it, but the cup is still there, and I'm thinking there might be a dead zone or something. I don't know. It just doesn't make me happy. So I went through and I found an old engine that I had already kind of built the motor up already, and I thought I'd get the motor out and go through it again and make sure it was as good as I can get it, and then put it in that engine and see how that performance runs. So I just got it up, and I'm going to turn it on. Oh, I didn't turn it on, did I? There it is. It's turned on now. I'm going to add some amps to it. I can turn the amps off and it won't run. Okay. So here it is spinning. You can hear it and see it. Right. And it's been polished and it's been set up. It's been lubricated and cleaned. It's as good as I can get it. New brushes, new springs, and good oil. And it's pulling less than a half an amp at 2.8 volts. Now that's without a load. So with the load, it probably wouldn't be turning, okay? But this tells us the condition of the armature and the bearings, and are the fields working and all that good stuff. So this is what the engine motor is doing. So what I do is I slowly increase this. So we'll start out, say we want to get to 5 volts, and we get to 5 volts and we're at 0.5 amps. A little bit of vibration, but that's common. But it's fairly smooth. If I pick it up off the table, it's just a Hummer, literally. Okay. So now we're going to take it up more into the range of 6, 7, 8 volts, 6.6 amps. We haven't even hit 1 amp yet. So 1 amp is not much, so it's really running smooth, and it's not using a lot of energy to move. So it's freewheeling, you might say. It has a smooth action, okay? Now, it may sound like it's screaming at 200 volts or whatnot, but it's only 12 volts, and it's 0.7 amps. That's a little over 15, almost 16 volts. That's near full speed at 0.8 amps, not 1 amp. I'll take it up to 17. That's usually about the limit. So there's a good speed. It's still humming. It's just churning at 0.8 amps. So this is a very, very good running engine. When I tip the throttle in at low voltage, it takes 1.6 amps to get up to speed, and then it levels off at 0.5. So that's pretty good. This is an excellent engine, an excellent motor. I'm a car guy, so I have engines. Okay, but this is excellent tune-up to this motor. So I'm excited to put this motor in this engine, and I think that's going to take care of that pulsing. Maybe it'll take care of the pulsing, but I think it also will take care of that one moment of non-start, which I didn't like. I mean, that's not right. It should be able to start. So. And that'll give me time to take that engine down and do more to it later as I need to, and replace it in a different engine. So that's what I'm going to do now, swap motors. Take this thing out and put it over there and get going. All right, later. Well, it took a lot longer than I thought to get everything back together, but there we are. And it's running smoothly. I disconnected the power in order to run my DC motor. I'm running out of time, so I may not get it all back together today. That's 10 volts. That's 13, 14, 15, 16, 17, 18. Oh, back. There's 17. 17 volts with the gears, 1.1, 1.0 amp, 1 amp, 17 volts. And it's humming. It's a Hummer. Not gear lube. Synthetic multi-oil. Just put a few drops in on those bushings. Keep them lubricated. The gear's got white grease all over it. It's a Hummer. Hard to stop. Very hard to stop. Yeah, warms up your hand. Should pull, right? Okay, now let's see what happens when I turn it all the way down. Yeah, it'll turn over at 3 volts, 7.8 amps. Got a little draw on it. 3 volts. It'll turn over with a gear. It's pretty good. So it's lubed, it's accurate, it's balanced, it's polished, it's blah blah blah. New springs, new brushes, ball bearing in front, and ball bearings on the axle. One wheel's a little wobbly. I can straighten him out. So, okay, now the challenge I'm going to try to do is plug in the board and run it off the amp. Let's try that real quick. Oh wow, that was better than I thought. It just started right up. I'm at 30 miles an hour. Now it has no power, I think. I can stop it probably. Oh yeah, I can stop it. But it does pick up again. So you're going to give it a little more juice. Get it up to 40. 50. Oh, listen to that thing. When you don't have it vibrating on the table, it's just a hums. 60. 70. 80. You know, no, you're not stopping it. I'm not putting my hands in there. 90. If it jumps a track, it's going to run into the wall. That's flat out. That's 100 on my, what is this again? I never remember. I think it's a B4. Yeah, B4. 4B, I guess. It's pretty good. 100 watts. Pretty good. Pretty good. Okay, I'm thinking we're good now. I don't have a lot of time to put it together. I don't want to rush. Plus, I want to do some work on this board here for that rattling thing, you know. And I wanted to get back to Robert about this motorboard and see what's it take to lower that delay. Nice. Okay, I'm gonna call it quits, guys. Oh, what a day, huh? Well, I thought that motor had problems, and I think it did. So I took it out, and I'll test it. I've got it here to try out. It's like a short block or something, maybe a long block. Find an old Chevy somewhere, throw it in, see what it'll do. Who knows? Okay, call it quits. This is a good post. It's only 10 minutes, a lot shorter than yesterday. I was not competing with anyone in their speeching lengths, but I just let it go and thought you might like to see the details. Maybe not. Okay, check in later. Bye for now.